Okie dokies, artichokes. Today in this lesson, we learned about how to do equals values method, but you only learned how to do it when the equations are in the form y equals mx plus b, which is the form we're very used to. Now, at the very beginning of chapter 5, we looked at a form called standard form, which is where you have x and y all on the same side, just like these guys right here. Okay, now on the test that you're going to take at the end of chapter 5, which is coming up quite quickly, you are going to be expected to be able to transform standard form to y equals mx plus b form and solve with it. So I want to show you that today as a bonus kind of ending video. So I have for you two equations here that are in standard form. In order to get them into y equals mx plus b form, I need to solve each of them for y. So we're going to start that one out. And as a bonus, it may make this video a little longer. We are going to look at a different method to solve this that does not involve having to turn them into y equals mx plus b. So if I want to get y by itself, this 6x right here is bothering my y, so I'm going to move it over here. Then I have 2y equals 6x plus 14, or 14 plus 6x, either one's works. And then I'm going to divide everything by 2. And I end up with y equals 3x plus 7. Okay, this is a pretty standard looking equation. Remember that if you have two y's, then you need to divide everything by 2, because I also have two sets of x's and two sets of units. So I should have a single y equals 3x plus 7. Okay, so we've done the first one, so now we have to do the second one. Our second one is y plus x equals negative 1. This one should be a lot easier. I want to get y by itself again, so I'm not going to touch my y. I am going to subtract an x from both sides. That becomes 0, and I end up with y equals negative x minus 1, or minus 1 negative x. They're the same thing. Okay, so now I have both of my two equations. Using equals values method, or as we're calling it, EVM, because that's really annoying to say, I want to know when these two are equal. So what I'm going to do is I'm going to set them equal to each other, aka put an equal sign in the middle. Boom, done. And then we're going to solve. So basically, I'm looking for what value of x makes these two actually equal, because at the moment, obviously, they are not equal. I'm looking for what value of x would make them equal. So I like to say always move the smaller one or the negative one. Negative's automatically smaller, but we can debate semantics. So I have a negative x. I'm going to move that one to get rid of my negatives. You may be wondering, how does that get rid of the negatives? Well, because I have to add an x to both sides, it becomes a positive. And this side becomes a 0, so I don't have to deal with it anymore. I'm left with 4x plus 7 equals negative 1. Now here's a fun fact. In this case, there's no way to avoid a negative. It will end up. Because I have a negative 1 here, I've already isolated my x's on this side, so I have to get rid of my 7, which is just going to make this more negative. And that's okay. I think in all cases, you want to try to avoid a negative x. If you end up with a negative unit, that's fine. So negative 1 minus 7 is a negative 8. But you can see my x's are positive, so I'm still doing good. I'm now going to divide by 4 on both sides because I have 4 sets of x's. I end up with a single x equals 2 negative unit tiles. Okay, so x equals negative 2 is when these two are equal to each other. Now on the test, when I ask you to solve a system, I'm going to ask you for the POI, or point of intersection. So I know that the x value is negative 2, and now I just need to choose one of my equations to plug the negative 2 back into. So I'm going to do this one. Assuming you did it correctly, they should both be the same. If you ever think you did not do it correctly, plug negative 2 into both sides. If they don't come out to be the same answer, you have done something wrong. I think I'm going off the screen. I am. Cool. Okay, 3 times negative 2 is negative 6 plus 7 equals 1. Just because I want to show you, let's test this out on the other one as well. So I had a negative x here. So if I put in a negative 2 for x, it's going to be a negative 2, right? And if you know anything about negatives, a negative times a negative makes a positive. It's kind of cool. See, it made a plus sign. Wasn't that cool? Anyway, okay, I'm going to stop talking now. 2 minus 1 equals 1. So they equal the same thing. I did good, and this means that my y-coordinate is 1. So my point of intersection would be at negative 2, 1, if I drew the lines. Okay? This is equals values method. Now, if you don't want to learn the other trick, you can move on. It's only 5 minutes, so nice short video. But if you want to learn the other one, stick around. Okay, we're going to use the same set of equations so I can show you that I get the same answer. This method is called substitution method. Now, this used to be taught in 8th grade. It's now taught in 9th grade. But, you know, it's the pandemic. The more you know for 9th grade, the better off you're going to be. And if you like the substitution method, feel free to use it. That's how we used to do it in the old days. We've just changed things up. So the substitution method means that I only need to change one of these two equations into y equals mx plus b. Because what I'm going to do, and I will show you in just a second, I'm going to substitute whatever variable I isolate into here. That sounds a little confusing, but trust me, it'll make a little bit more sense once I get going. With the substitution method, I always recommend finding the simpler of the two equations. So in that case, that's this one right here. So I'm going to solve this for y. Oh, sorry. Plus x equals negative 1. I need to subtract an x from both sides, just like I did in the back. And I end up with y equals negative x minus 1. Okay, those should be the same. Let's go check, make sure. Yep, those are the same. We're good to go. We're a little fuzzy today. There we go. Now we're focused. Now that I have this, what I'm saying now is that y equals negative x minus 1. According to the substitution method, that means that this y, because it's all in the same problem, also equals negative x minus 1. So what I'm going to do is I'm going to pull down, let's do a different color so you can see this. Pull down that problem, but instead of writing y, I'm going to substitute in negative x minus 1, because that's what I said y equals, right? Ta-da! And now my goal is to solve for x. So we're going to draw our little line. Now in most of the problems we've been doing today, there's been no distributing, no simplifying. It's just been straight on to isolate it and sort it. Possibly move it. This one though, we need to distribute right off the bat. So we're going to do distributive property. So remember that is multiply everything on the inside by the outside. So everything needs to be multiplied by 2. 2 times negative x is negative 2x. 2 times negative 1 is a negative 2. And then we have this negative 6x that's still just hanging around. Change color. Now that I've distribute, I now need to simplify. Because if you take a look at this guy, he has multiple sets of x's, which I don't want. So what I have here is I have 2 negative x's and then another 6 negative x's. If I add those together, that gives me 8 negative x's. And now I can solve like I normally would. So my x's are already isolated, which is the super nice thing about substitution method. Typically the variable is already isolated, so you just have to get rid of your units. So I'm going to add 2 to both sides. And then with negative 8x equals 14 plus 2 is 16. I know I have now ended up with a negative variable. That happens. All I need to do now is I have negative 8x's, so I'm going to divide by a negative 8. These guys cancel out. I'm left with 1x left. 16 divided by 8 is 2. Because of this pesky little negative, though, it is a negative 2. Voila. And if we go take a look, I got negative 2 in the last one, too. Okay, same idea. All I need to do now, if I want to find y, so remember we have to do a POI, negative 2, and I want to know what my y coordinate is, I can just go back up here and plug it into this one. You can plug it into this one, but it means you're going to have to solve for x again. So I'd recommend plugging it into the one you've already transformed into mx plus b. Negative times a negative makes a positive. 2 minus 1 equals 1. Boom. Done. This, I have to admit, is one of those things that either comes really easy to you or it takes forever to figure out. So if this one comes really easy to you and you're like, I would like to use the substitution method from now on, feel free to. It's a little tidbit you learned before high school. If it didn't come easy to you, feel free to ignore it and just go with the equals values method, right? Just transfer everything into the y equals mx plus b format. The only difference between the two is that in equals values method, you get everything in this format. In the substitution method, you only get one in this format and you can leave the other one in standard form. But it's really up to you. I just wanted to point that out. We will do a lot more practice with equals values method in the next lesson. Also, you'll get practice with substitution method in high school, so don't feel pressured to learn it right now. Just a cool little tidbit. Anyway, have a great day. Say hi to somebody, smile to somebody. Everyone can use a smile. And I will see you in the next lesson. Goodbye.